Hello everyone, welcome back to Let's Crack J in English, the channel of Unacademy, and I am Jeetendra Dixit. Here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So today we'll continue circles, and in this session I'm going to discuss family of circles. Okay, so I'll tell you all the forms of family of circles in which they are used. Okay, but before we begin, let me also tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and if you are preparing for IIT-JEE, then you can have two types of subscriptions on Unacademy. One is Plus subscription and another is Iconic subscription. In Plus subscription, you get access to daily live classes of all the educators who are teaching for IIT-JEE. You can watch the live sessions of educator of your choice. You have complete freedom on the platform. So in a way, I can say you will get unlimited access on the platform. All right, and all the live tests and quizzes will also be accessible to you. These live classes are very interactive. You can chat with your educator during the live session. You can ask your doubts also, and there are separate doubt sessions as well. And all the courses which I'm talking about are well structured, so you can join uh, any course or of any educator. All right, you can join a team or you can follow individual educator also. You have all the freedom. So this is about the Plus subscription. So in short, I should say that you will get unlimited access on the platform once you have this subscription. All right, you can subscribe for 1 month, 3 months, 6, 12, and 24 months. And the left hand side you can see the price list. It is 7,000, 7,500, and 17,500 for 3 months, and 6 months it is 38,000. For 12 months it is 38,500, and for 24 months it is 56,000. All right, just a moment. All right, and 12 and 24 months you can compare these. These are the economically best prices you can Academy is offering for you, because per month if you compare is that's 3,208 and 2,333 for 1 and 2 years respectively, and on that also you'll get 10% discount instantly. So you can use educator's code, and you can use this Jeet one also. This is my code. Using this code you'll get instant 10% discount in all the subscriptions which you can see. So right hand side you can see price list is given with after 10% discount. All right, now next is Iconic subscription. In this subscription you can you'll get all the benefits of Plus. So whatever I have told you in Plus subscription, you'll get that. And apart from that, you'll get a personal coach as well, who will guide you throughout your preparation for IIT-JEE. Your test analysis will be done in a personalized manner. Your study planner will be customized. Bi-weekly reviews will be given to you. All right. So in short, you'll get a personal attention of an expert who will guide you throughout your preparation. So this is Iconic subscription, and Iconic subscription you can take for 6 months, 12 months, and 24 months. This is the price: 38,000 for 6 months, 65,000 for 12 months, and 1 lakh for 24 months. And you'll get 10% discount as well using the same code. You can use any educator's code. You can use the Jeet one also to get instant 10% discount. And this is an Academy's learning app which you can download from Play Store, and after downloading it, you can start attending free live classes. Okay, free live classes are also taken by the top educators of an academy. So different topics are covered in that. Every day a lot of special classes are going on, and you can attend unlimited special classes on the platform. So if you are a new learner, you need to use the code of an educator. So you can use the same code JEET1 to access all the free live classes. You don't need to pay anything for that. Okay, and this is the information about Spark batch for class 11th, which is starting from 21 December. All right, so you can see the all the top educators who are taking this uh, Spark batch for JEE Main and Advanced 2023, and JEE Main and Advanced MCQ batch. Again, this is starting on 20 started on 21st December, and again you can see the top educators who are teaching this batch, MCQ batch, okay, for JEE Main Advanced 2021. Now let's begin the session. So as I was telling you that today we are going to cover family of circles. family of circles. So as I told you earlier also that S1 is equal to 0. I'll do a quick revision of family of curves. Okay. So if S1 is equal to 0 and S2 is equal to 0 are two intersecting curves. Two intersecting curves. They might intersect at 1 point, 2 points, or 3 points, all right, or more than 3 points also. Because in case of 2-degree curves, maximum number of points of intersection can be 4, okay, in 2-degree curves. So S1 and S2 are suppose 2-degree curves and they are intersecting at certain points. Say, let's say in this diagram, I'm showing you 2 points. Then S1 plus lambda S2. S1 plus lambda S2 is equal to 0. This lambda is any parameter, lambda belongs to any real numbers. This represents a new curve, which passes through all the points of intersection of S1 is equal to 0 and S2 is equal to 0, okay? So this S1 plus lambda S2 can be any curve, it can be a circle, it can be a pair of straight lines, it can be a parabola, it can be, so for different values of lambda, it can be any curve. But this curve will always pass through all the points of intersection of S1 and S2. Why? Because if say this X, let's say A, X1 comma Y1 is the point of intersection of S1 and S2. So it will satisfy both the equations S1 as well as S2. That means if you put x1, y1 in S1, it will become 0. 0 is equal to 0. And if you put this point in S2, this will also become 0. Similarly, if you put this point in this new equation, which is S1 plus lambda S2, this equation, this point will also satisfy this equation because S1 will become 0 as well as S2 will become 0. So that means S1 plus lambda S2 will also be 0, right? So hence we can say that all the points of intersection of S1 and S2 will satisfy this new curve which we have written in this form S1 plus lambda S2. Alright, so I hope now this point is clear. Now we are taking these two curves S1 and S2 as circles. Okay, now suppose, so I'm taking the first point, okay, first very basic point, that S1, let S1 is equal to 0 and S2 is equal to 0 represent two circles. All right, two circles. First circle is S1 I'm taking as x square plus y square plus 2 g1x, general equation, plus 2 f1y plus c1 is equal to 0. All right, and S2 I'm taking as x square plus y square plus 2 g2x plus 2 f2y plus c2 is equal to 0. All right. Now, if I write S1 plus lambda S2, then what will this represent? This will represent, and S1 and S2 are two intersecting circles, okay? These are two intersecting circles. I'll introduce this word, intersecting circles, all right? Then it will make sense. All right, so two circles are intersecting. Obviously, two circles can intersect maximum at 2 points, all right? And they can touch each other at 1 point. So we'll take that case also later. So S1 plus lambda S2 are two intersecting circles. That means they are intersecting at two different points, all right? Then S1 plus lambda S2, what this curve, new curve will represent, okay? You know, lambda is a parameters, so you can take lambda is equal to 1, lambda is equal to 2, lambda is equal to half, lambda is equal to -1, lambda is equal to 0 also. If you take 0, it will become S1 only, right? So this represents a family of curves, okay? I'm saying curves, okay? Family of curves passing through points. Say A and B are the points. A and B are the points of intersection. So this will represent all the curves passing through S1 and S2. That means A and B, all right? But again, now listen to this carefully. I'm saying that for all values of lambda except one value, that is -1, this will always represent a circle actually. So rather saying that it will represent a family of curves, we can say that it will represent a family of circles because parabola is not possible in this combination. Why is it not possible? Let me tell you. If you put the values of S1 and S2, it is going to be if I simplify, first let me write the complete expression, x square plus y square plus 2 g1x plus 2 f1y plus c1 plus lambda times of x square plus y square plus 2 g2x plus 2 f2y plus C2 is equal to 0, all right? So now you can see it is 1 plus lambda into x square plus 1 plus lambda is equal to y square plus 2g1 plus 2g2 lambda, all right, into x. Similarly, plus 2f1y plus 2f2 lambda. Okay, let me take y common. Now, this into y plus c1 plus lambda c2 is equal to 0. Now you can see that coefficient of x square is equal to coefficient of y square, and there's no term of xy. So in such case, when coefficient of x square is equal to coefficient of y square in 2-degree equation and there's no term of xy, that means coefficient of xy is 0, then that equation represents a circle. That circle might be of real radius or imaginary radius, that's a different case, different thing, but it will represent a circle. We call it a circle, all right? A circle can be of imaginary radius also. So for real radius or imaginary radius, we can apply separate condition on g square plus f square minus c. That should be positive or negative for real or imaginary radius. But for lambda is equal to minus 1, you can see for lambda is equal to minus 1, that is the only one value for which this x coefficient of x square and coefficient of y square will become 0, and it will become a line, right? And that will be a line which will that will also pass through the points of intersection of s1 and s2. So for lambda is equal to minus 1, it will become a line, and that line is nothing but the common chord. Okay, I have already taught you in previous session that s1 minus s2 is equal to 0 represents the line which is called common chord if circles are intersecting. If circles are not intersecting, then it will be something else also, all right? But here, because in this case circles are intersecting, we can call it common chord, all right? So now I'll write it like this: s1 plus lambda s2. Okay, s1 and s2 are circles where lambda belongs to r minus minus 1. Okay, I'm just removing this value. Lambda is not equal to minus 1 will always represent a circle passing through the points of intersection of s1 is equal to 0 and s2 is equal to 0, all right? Now see, and if lambda is equal to minus 1, then s1 minus s2, this equation will become s1 minus s2 will represent their common chord, all right? So now we have got the meaning of family of circles. Whenever you are adding two circles by multiplying the equations with some parameters, this equation will always represent a circle or a line in one case, okay? Or a line in one case, which is common chord. Otherwise, it's a circle passing through their points of intersection, okay? That's why we call it family of circles rather calling them family of curves. Okay, we can always call it family of curves if we are not sure which type of curve is this. Okay, but if we know that it is a line always, then we can call it family of lines. If it is a parabola always, we can call it family of parabola. If it is a circle always, then we can call it family of circles. So like in this case, it is always a circle, so we are calling it family of circles. All right, so this was the first case. Now let's take the second case, okay? So what is the second case? Now in this case, s is equal to 0 is s is equal to 0, and so I hope this point is clear, the first point. Now I'm making a family of circles using two different curves, one circle and a line, okay? So s is equal to, let s is equal to 0 and l is equal to 0 are intersecting circle and line, all right? So now I'm taking a circle and a line. Now see, if I make a family using these two curves, a line and a circle, then what will it represent? All right. So this is a circle, S is equal to 0, and L is equal to 0 is a line. All right. L is equal to 0 is a line. So these two curves are intersecting again at A and B. This is S equal to 0. If I write this equation, S plus lambda L is equal to 0. I'm taking L as suppose AX, LX plus MY plus N. All right. So S is same, X square, and S is say X square plus Y square plus 2GX plus 2FY plus C. All right. This is S. S is equal to 0, L is equal to 0. If I add them, let's see what does this represent. It is x square plus y square plus 2gx plus 2fy plus c plus you can see it is lambda times of lx plus my is lx plus my plus n is equal to 0. All right, and you can say it is x square. Now you can see coefficient of x square and coefficient of y square are 1 in this case only, right? Because in line there's no term of x square and y square, so there's no change in the coefficients of x square and y square. Similarly, there's no term of xy, that means coefficient of xy is still 0, so it will represent a circle only, because coefficient of x square is equal to coefficient of y square, no matter what is the value of lambda in this case. Okay, so lambda can take any real value, like not like the previous case in which you are removing -1. In this case you can take even -1 also. So x square plus y square plus 2g plus lambda L into x, you can write like this, plus 2f plus lambda m into y plus c plus lambda n, all right, is equal to 0. So this always represents a family of circles. Okay, so now we can conclude it. It represents a family of circles passing through A and B. Okay, so all these circles, you can make circles, you can make any circle. This white circle is represented by s plus lambda L. This another circle is represented by s plus lambda L. All right. Okay, now also compare the previous equation. If given an option that you need to make a family using two circles or one circle and a line, then you should always choose a line and a circle, because that will involve less calculation. See this previous equation in which you added two circles, this was the equation you were getting. So in which coefficient of x square and coefficient of y square is not 1, so that means you'll have to divide by 1 plus lambda to make coefficient of x square and coefficient of y square 1. And then writing centers or radius, 1 plus lambda will be in the denominator. While in this case, uh, it is not so, because x is coefficient of x square and coefficient of y square is already 1. So you don't need to divide by any number in this case. Okay, so it will involve less calculation. That's why I'm saying that if given option, if you have an option to make a family of circles using a line and a circle, then you should make it using line and circle only. Okay, now I am telling you, now let's come back to the first point in which two circles are given. Okay, s1 is equal to 0. This is the first point. I'm repeating it again. Okay, so s1 is equal to 0 and s2 is equal to 0 are two circles. Then we can rather writing s1 plus lambda s2, we have another way of writing family of circles using these two circles. First we'll write the common chord. Okay, so common chord is s1 minus s2 is equal to 0. It's a line, right? This is a line. So now we have got a line which is also passing through the same points where these two circles are intersecting. All right, so now we have got three curves, two circles which were already given, and we have got this line using s1 minus s2. All right, this is s1 minus s2. s1 minus s2 is equal to 0, s1 is equal to 0, and s2 is equal to 0. We need to write the family of circles passing through A and B, right? That is our purpose. We can write this s1 plus lambda s2, which we have already learned, but now you know we have a line also passing through the same point, so you can use S1 or S2, any circle, doesn't matter, one of the circle plus this common chord, lambda times of S1 minus S2. Okay, so if you do so, then that coefficient of x square and coefficient of y square will remain 1, and this will be a simplified version of first equation. Okay, first family which I have written. This is also representing the same family. This is representing a family of circles, passing through the points of intersecting of S1 is equal to 0 and S2 is equal to 0, alright? So rather using this equation, the first one, this one, S1 plus lambda S2 is equal to 0, you should always use this equation, okay? So now we have modified our first equation in this form. This will involve less calculation. You directly need to, whenever two circles are given, always write the equation of family of circles using this equation, S1 plus lambda times of S1 minus S2 or S2 minus S1, that doesn't matter. Similarly, whether you use S1 plus lambda times or S2 plus lambda times, that also doesn't matter, all right? You can use any circle, any one of the circle and the common chord. So I hope this point is clear. Now let's see what happens. What happens when these two lines, line and tangent, are given? Okay, circle and tangent, circle and its tangent. That means a line is given which is touching the circle, not intersecting. Okay, so if S is equal to 0 is a circle and L is equal to 0 is its tangent. Same as x square plus y square, I'm taking this x square plus y square plus 2gx plus 2fy plus c is equal to 0, and line I'm taking as lx plus my plus n is equal to 0, alright? Now, in this case, it is given that line is touching the circle. So what happens when you use same family of circles equation, s plus lambda l, what that equation will represent, all right? So this is the point where this line is touching. So if you use this s plus lambda l, you know this will represent a circle only, okay? You know the logic, because you're adding linear terms to the equation of a circle, which will always represent a circle only, all right? So it will represent a circle only. But which circle is this? Okay, which type of circle is this? That is our main concern. So S plus lambda L is equal to 0 represents the family of circles passing through point A only. Okay, I mean it will touch. So these circles basically touch the given circle and line at their point of contact. So these are the circles which will be represented by this equation S plus lambda L now. Okay, we are sure about this, that all these circles are passing through point A, but they will not pass through any other point. I mean, let's say B is another point on the circle. It will not satisfy the equation. You can see if I put this point B, coordinates of point B, which is x2, y2 say, in this equation, then S will become 0, but L will not become 0. Similarly, if you take a point on the line other than A, say point C, which is x3, y3, then x3, y3 will also not satisfy, because this L will become 0, but S will not. But if you put this point A, which is x1, y1, we don't need to know this point. I'm just explaining it, okay? That all these yellow circles are passing through only point A and not meeting the given line and the given circle at any other point, all right? So that means they are tangent to the given curves. Tangent means they are touching the given circle and the given line, all right? So this represents a family of circles passing through the point of contact of S is equal to 0 and L is equal to 0 for all real values of lambda. All right, so now that is the case. And this is a very, very, very important point. So whenever you have a circle and its tangent, you can use this equation to write any other circle which touches these two curves, or which touches the curve at their point of contact. All right. Now I'm telling you the fourth. This was the third case. Okay, this was the third case. So first we'll finish all the cases and then we will start our practice questions, examples. Just a moment. All right. So I'm taking the fourth case. In this case, family of circles. I'm writing a family of circles. Now we know two basic things we know. If a line is given and a circle is given, then S plus lambda L represents. That is the main point of now of all the points which I'm going to explain. What is the main point? That if a line is given and a circle is given and they are intersecting at 2 points or maybe they are tangent to each other, then S plus lambda L will represent a family of circles passing through their points of intersection or their point of contact. All right, simple. So now family of circles touching circle S is equal to 0 at say point P, x1, y1, okay? x1, y1 is a point on the circle. Obviously, then that's why, then only this line which will touch the circle. Okay? So now say this is the point P. This is the point P, x1, y1. Now we know, now equation of circle is given, but we don't know the equation of line which is passing through this point. I mean, which is touching the circle. If we get that line, I mean tangent at point P, then we can use S plus lambda L and we can write the family of circles. So can we write the equation of tangent at point P? Yes, of course. So first, what is the first point? In this case, the first point is to make that line, okay, to create that line. So tangent to S is equal to 0 at P, x1, y1. You know, if a point is given on the curve, then how to write the tangent? It is T is equal to 0. It is T is equal to 0. So that is the equation, T is equal to 0. All right. So T is equal to 0 represents the tangent, and it is actually, you know, the equation if I take S is equal to x square plus y square plus 2gx plus 2fy plus c, all right, then t is nothing but I'm writing t with respect to x1 y1, x1 plus y1 plus gx plus x1 plus f y plus y1 plus c, all right. So this is line L. So S plus lambda L, S plus lambda L is equal to 0. S is the given circle, L is the line which we have, we have written the equation of tangent, that is the line. So S plus lambda L will represent the family of circles where lambda belongs to M, any value of R, alright. So in this case, line was not given. We have written the line. Which line we have written? We have written this line, alright. We have written this line and then we are using S is equal to S plus lambda L, okay, and it will represent all the circles which are going to touch the given circle at point P, all right, at point P. So if any question, if he asks you to find the equation of a circle which touches a given circle at a given point, then you can use this equation. This will help you, to find the equation of the given circle easily. Okay, this is a very, very important point, actually, very, very important point. We'll use this point in other curves also, like in parabola, and ellipse and hyperbola. All right. So I think this point is clear. Circle was given, a point was given on the circle. Okay, and now we have written a family of circles which will touch the given circle at the given point. All right. Now suppose, now this is another point which is again very important. The fifth point is family of circles touching a line L is equal to 0, okay, at point P, x1, y1. Now in this case a line is given and we need to write the family of circles. So this is the line which is given okay? And we need to write the family of circles which are touching this line at this point, x1, y1. Okay? All these circles are represented by, so I'll tell you how to write this. I'm just making the diagram, okay? So we need to write the general equation for all these circles, okay? First, we need to, now, like in the previous case, a circle was given and we created a line. In this case, a line is given and we need to create a circle. If we know any one of the circle which is touching this line at point P, then we can use S plus lambda L, and after using it, we can write the equation, all right? S plus lambda L. Simply, we can use that S plus lambda L. So now let's see how to write circle. In this case, the easiest we can write, you can write equation of infinite circles, okay? But the easiest case is to choose a circle of 0 radius, okay? That means a point circle, okay? So point circle means circle of 0 radius, okay? S is given by x is x minus x1 square, all right, plus y minus y1 square is equal to 0 square. Radius is 0, all right? So this is a point circle which we are going to use, okay? So this point is also representing a circle actually. And if you use S plus lambda L, okay, if you write this equation S plus lambda L, it will basically represent a circle, okay, of any radius. So lambda belongs to R. For different values of lambda, it will represent a circle which will pass through x1, y1, of course, because why? Because x1, y1 will satisfy this S is equal to 0 and as well as the line, okay? So if you take line as Lx plus my plus n is equal to 0, all right, then you can use this x minus x1 square plus y minus y1 square plus lambda times of the line Lx plus my plus n, all right? And you know this x1 y1 is going to satisfy this because you can clearly see this will become 0, and because this point is on the line, so this will become 0, all right? So S plus lambda, and it's a circle, okay? And it's a circle. You know that coefficient of x square is equal to coefficient of y square in this equation, and there's no term of xy. That means it's a circle. So it will represent a circle passing through x1, y1 and touching the line at that point, okay? So this is a family of circles, and this is again a very important point, okay? And again I'm telling you, this point we'll use in all the curves. Whenever you need to find, I'll tell you the example where we are going to use. Suppose a curve is given. This can be any curve, and you need to write any curve. You need to write a circle touching this curve at this point. So what are we going to do? First we are going to write this tangent, okay? So we'll get this tangent L is equal to 0. Then we can use this equation, point circle and this line, which will give you a circle touching this line at this point. And because line is touching the given curve, so this circle will touch that curve also, okay? So in that way we will get a circle, equation of circle touching the given curve at the given point, all right? So that means we are going to generalize this for any curve like parabola, ellipse and hyperbola, all right? So I hope this point is also clear. One more point I'll tell you, and after that we'll start practicing some questions. Now the sixth point is family of circles passing through 2 points, say A x1 y1 and B x2 y2. So now in this case neither a line is given nor a circle is given, all right? So only 2 points are given, and you know from 2 points infinite circles can pass from 2 points, through 2 points. So now we need to create a circle as well as a line. How to create that? If we get a circle passing through these 2 points and a line passing through, of course we can write a line passing through these 2 points easily because there's a unique line passing through these 2 points, all right? But there are infinite circles. So we need to choose one circle which we can write easily, okay? Without any efforts. So this is the line which we are going to create, and this is the circle which we are going to create, all right? So line we know, line is simple. Line passing through two points, y minus y2 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. This is the line. And a circle you can write x minus x1 into x minus x2 plus y minus y1 into y minus y2. Which circle is this, by the way? This is a circle whose diameter is AB, okay? So I've chosen a circle now using A and B as the diametric endpoints. Yes, you can use any circle, okay? So I've taken a circle whose diameter is AB because I know diametric form of a circle. So if endpoints of a diameter are given, we can write the equation. We can write the equation of circle easily. Okay, so I'm using this equation, and now we can use S plus lambda L. Okay, now if I write S plus lambda L, it will represent a family of circles. Family of circles passing through A and B. All right, for all values of lambda, all right, belonging to real numbers. So this was the sixth case, all right. So now I've told you most of the cases. Now let's begin some questions based on family of circles, all right. So I'm starting with this. Question number 1, find the family, find the circle, not family, sorry. Family is something which you need to use by your own, okay? It won't be mentioned in the question because you can use any other method also. And in case of circles, yes, you have other method also. Uh, but using family, it will be easier to solve the question and less calculation most of the cases. So find the equation of circle passing through um, minus 1 comma 2 and touching the circle x square plus y square minus 8x plus 6y is equal to 0 at origin, okay. So you can see origin is lying on the circle, right? You can clearly see that because there's no term of constant, so that means origin is lying on this curve. So try this one for a minute and then I'll tell you the solution. All right, so let's do it. So as I told you, we need to write the circle is given, a point is given. We need to write the equation of tangent first, okay? Then we can use family of circles. So you know how to write the tangent, t is equal to 0. So simply you can say if this is S, then S plus lambda t is equal to 0 is family of circles passing through this point, actually touching the circle at point A, which is origin in this case, all right? So let's write t. So at origin you need to write the tangent. So S is x square plus y square plus 6y minus 8x plus lambda times of, okay? So it is x into 0 plus y into 0 minus 4 times of 2x can be written as x plus 0 and plus 3 times of y can be written as y plus 0 and this whole thing is equal to 0, all right? So now this is the equation of family of circles. So it is x square plus y square plus 6y minus 8x plus, let's simplify it. So it is uh, 3 lambda x, 3 lambda y and minus 4 lambda x, okay? If I club all the terms, it is x square plus y square minus of 8 plus 4 lambda into x, all right, plus 6 plus 3 lambda into y is equal to 0, all right? So this represents the family of circle passing through, touching the given circle at point A, at origin basically, okay? But we need a certain member of this family. That means we need a one particular circle which is passing through minus 1 comma 2 as well, all right? So if this circle which we need from this family, belonging to this family, is passing through minus 1 comma 2. So if we put minus 1 comma 2, for that particular circle we'll get the lambda, and if we get the lambda we'll put in this equation, put the value of lambda in this equation, we'll get that particular circle, all right? So now put minus 1 comma 2 in this equation, minus 1 comma 2, put करेंगे, so we'll get 1 plus 4 minus 8 plus 8 yeah, 8 minus 4 lambda, we are putting minus 1 comma 2, all right? Minus 1 comma 2, so minus 4 lambda plus 6 plus 3 lambda into 2 is equal to 0. Let's simplify it. So it is plus 4 lambda and 6, so 10 lambda. So 10 lambda, and if I club the constant, it is 5 minus 8 plus 12. So it is, let me check it again, 5 plus 12, 17 minus 8, so it is 9. So plus 9 is equal to 0, and we'll get lambda is equal to, let me check, lambda is equal to what, if it is coming correct. Let me check it again. It was minus 4 plus 4x. Yeah, so x square plus y square plus 6y minus 6y minus 8x. Let me check the calculation. 6y minus 8x, yeah, and plus 3 lambda y minus 4 lambda x. Okay, so 6 plus 3 lambda x again y, and 12 plus 6, and this is minus 1, so 8 plus 4 lambda, 8 plus 4 lambda. All right, so we are getting this value. So I was just checking the calculation. It seems all right. So 5 minus 8, okay, 5 minus 8 and plus 6. So yeah, plus 12. So 8. So lambda is equal to, we'll get lambda is equal to minus 9 by 10. Okay, and we'll put the value of lambda in this equation, we'll get the circle. All right, so this is the method which we need to use. All right, now let me give you another example. Find find the equation of circle which passes through the points of intersection of x square plus y square is equal to 9 and x plus y is equal to 2. All right, and again, let me add the word here. Find the equation of smallest circle. Okay, so these two given circle and a line are basically intersecting. You can check it, easily. Distance from center to distance of its line from center of the circle should be less than radius. If that is the case, then line is intersecting circle, and if that is the case, then of course it is given intersecting, so you don't need to check, by the way. Okay, but still, if you want to check, you can check it. S plus lambda n you can use. Okay, and we need to find a smallest circle. So just think about it. What is the condition for a smallest circle? Now this is a very, very good question. Okay, so try this one. All right, so let's solve it. Find the equation of circle which pass through the points of intersection of a given circle and a line. So in this case, you can see the circle is given. And a line is given which is intersecting the circle at 2 points. So we can write the equation of family of circles passing through these points A and B, which is s plus lambda l is equal to 0. So it is simply x square plus y square plus minus 9 plus lambda times of x plus y minus 2 is equal to 0. Okay, if I simplify it, it is x square plus y square plus lambda x plus lambda y and minus 2 lambda minus 9 is equal to 0. All right. Now you can see we can write the center of the circle. So center of the circle is basically minus lambda by 2 comma minus lambda by 2. Now we need a circle whose diameter is AB. Okay, so how do you use this point whose diameter? I mean, because the smallest circle will be the circle whose diameter is AB, right? I've directly told you this thing. The smallest circle is the circle whose diameter is AB, okay? Because for any other circle, AB will be the chord, and obviously diameter is more than any other chord. So circle will be of will not be smallest. So smallest circle is basically the circle whose diameter is AB, okay? And if AB is the diameter, then center of the circle will lie on AB, right? So the center which we have written lies on line AB, on line L is equal to 0, all right? So that was the condition, okay? First, we need to figure out that the smallest circle is the circle whose diameter is AB. Then how to use it? To use it, you need to put the coordinates of center of the circle, which you have written in general form, S1 plus lambda, S1 plus lambda, S plus lambda L, in the equation of the line, because that line is diameter. So diameter always passes through the center, all right? So in that way, you'll get lambda. So if I put in this equation, it is minus lambda by 2 plus minus lambda by 2 minus 2 is equal to 0. All right, so now you can see it is actually minus lambda minus 2 is equal to 0. So lambda is equal to minus 2. All right, lambda is equal to minus 2. And if I put the value of lambda, this equation of circle will become x square plus y square minus 2x minus 2y, okay, and plus 4 minus 9, so it is 5, okay, minus 5 is equal to 0. All right, so that is the answer. So I hope you have got this point, okay? Now I'll give you another question to solve. So you can use this family of circles. Just a moment. Now find the equation. Find the equation of family. Oh, sorry, not family. Every day I'm writing family. Find the equation of a circle. Equation of a circle passing through the points of intersection of circles. Now two circles are given, okay? S1 is x square plus y square minus 6x plus 2y plus 4 is equal to 0, and x square plus y square plus 2x minus 4y minus 6 is equal to 0, okay? And its center with its center on the line y is equal to x. So this is straightforward question compared to the previous one, okay? So compared to the previous one, this is quite straightforward. Try this one. All right, so in this case, we'll write S1 plus lambda S2 or S1 plus lambda S1 minus S2. Which one we should use? So I've told you that is the main point to give you this question. In this case, we are going to use the equation which I have told you after point 2, which is S1 plus lambda times of S1 minus S2, okay, is equal to 0. Let's write S1 minus S2 separately. So if you subtract S1 minus S2 or S2 minus S1, you can do. So it is actually x square plus y square minus 6x plus 2y plus 4 minus x square minus y square minus 2x plus 4y plus 6 is equal to 0. So x square y square will get cancelled. It is going to be minus 6 and minus 2 is minus 8x, all right, plus 2y plus 4y is plus 6y, and this is 4 plus 6 is 10 is equal to 0, right? So if you divide by minus 2, it is going to be, you can write it 4x. You can simplify it first. 4x minus 3y plus 5 is equal to 0, okay? So I'm going to use this, and you can use any one of the circles. So both circles are general circles, you can use any one. So it is x square plus y square minus 6x plus 2y plus 4 is equal plus 4 times of lambda into 4x minus 3y plus 5 is equal to 0, okay? And then you can write center. So center you can see is minus 6 plus 4 lambda divided by 2 comma minus and then minus of this, sorry, minus of this, and minus of 2 plus 2 minus actually 2 minus 3 lambda, okay, divided by 2. And it is given that center lies on the line y is equal to x. You can put in that. So it is actually minus 6 plus 4 lambda is equal to 2 minus 3 lambda. Okay, equate these x is equal to y, simple. So minus minus will get cancelled, 2 and 2 will get cancelled, and